A man is able to row at 4 kilometers in still water. He rows straight across a river. So let's draw our river. And we've got this man and he's going straight across at 4 kilometers per hour. The river is flowing at the same time at 3 kilometers per hour. Determine his resultant velocity. If he is being pulled across, going across the river and down the river at the same time, he's going to land up going in that direction. So we complete the parallelogram and we put the resultant in. Now what's interesting here is that we have a 90-degree angle, which means we have a 90-degree angle there. This is a rectangle, so that's 4, and that is 3. We are now in a position to be able to work out using Pythagoras what the resultant velocity is, and it turns out that r squared is equal to 3 squared plus 4 squared. R is equal to 5 kilometers per hour. And we now also need to work out an angle. I think they haven't told me about a bearing, they haven't told me north, they haven't told me south. So I'm going to use the river bank as a good reference point. So I put my little alpha in over there. I know the opposite side, sorry, this is 4, this is 3. I know the opposite side is 4, and I know that the adjacent side is 3. So I'm going to say tan of alpha is equal to the opposite side over the adjacent side, and alpha turns out to be 53 degrees. So my resultant is 5 kilometers at 53 degrees to the bank. A light aircraft flies at an airspeed of 180 kilometers due north. What is its ground speed if it is flying in a wind in a direction from the north? If it's from the north, it is a headwind. So it is going to be 180 degrees that it's flowing, that it's moving to the north, and then another 40 kilometers from the north against it. So it turns out to be 140 kilometers to the north. What about if it's going to the west? So I've got 180 kilometers that the plane per hour, that the plane is flying north, but the wind is from the west, meaning it is to the east. So that is 40 kilometers per hour. I now complete the parallelogram and I draw in a resultant. My resultant squared is equal to 180 squared plus 40 squared, and it turns out it's 185 kilometers per hour. Again, this side over here is going to be 180. I've got that over there is 40, that over there is 40. So if I'm going to look for the bearing angle, let's look over there, that angle over there is of interest. So I'm going to say tan of alpha is equal to my opposite side, which is 40, over my adjacent side, which is 180, and I land up with alpha being equal to 12 degrees. So it's 185 kilometers on a bearing, or at 12 degrees. Determine the resultant of two forces. One is 20 newtons in the direction of 60 degrees. So 60 degrees, 20 newtons. The other is 15 newtons at 150, 150 degrees, and 15 newtons. Turns out between 150 and 60 is a 90-degree angle, so I can now use any of my Pythag and my sine causes and tans. Put the diagonal in. R squared is equal to 20 squared plus 15 squared. So R turns out to be 25 newtons. What is the direction? I work out this little angle over here. Call it alpha again. Tan of alpha is equal to opposite over adjacent, because remember this is 15, and my alpha turns out to be equal to 37 degrees. But that's not a very meaningful number. I'd like it to be on a bearing. So if it's on a bearing, I'm going to take a look at this whole angle over here. That means I add 60 degrees to that, and it is 25 newtons at 97 degrees. 60 plus 37 degrees. Forces of 10 newtons in the direction 30 degrees. So we've got 30 degrees. We just need to draw a bearing line. There we go. And we've got 25 newtons. Sorry, that's 10 newtons. 10 newtons in the direction of 30 degrees and 25 newtons in the direction of 120. So I go all the way around here, 120 degrees, and that's 25 newtons. And complete the parallelogram. Again, I've got a 90 degree in this corner. And I go r squared is equal to 10 squared plus 25 squared. And I find that the resultant is 27 newtons. I'm interested in this angle over here, and I will add it to 30 in a minute. So I say tan of alpha is equal to opposite side. Opposite side is 25, adjacent side is 10. And I land up with alpha being equal to 68 degrees, added to 30, and my resultant is 27 newtons at 98 degrees. An aircraft flies due north at 200 kilometers per hour. Now I want you to notice that obviously I'm not drawing with a ruler on the tablet, but you need to draw these with a ruler, and you do need to always put an arrow head onto every single vector. The wind blows from the east, in other words, towards the west, at 50 kilometers per hour. And notice I'm also always writing kilometers per hour. I write the units. I write in my angles. So over here I wrote in 30. Over here I wrote in 120, wrote in 60, wrote in 150. Okay, so here we've got another obvious 90 degree angle, so we can do that. There's the 90. And we have to work out the velocity from the ground, so in other words the resultant velocity. And r squared is equal to 200 squared plus 50 squared. R turns out to be equal to 206 kilometers per hour. I do not have to measure these lines accurately because I'm able to calculate the answers, but that doesn't mean I can sacrifice neatness. Still need to have a ruler, still need to put my arrowhead on. What is the angle that I'm interested in? I'm interested in the angle on a bearing, so it is all the way around until there. So I'm going to calculate just this little angle here, and then I'm going to subtract it from 360 degrees. So I say tan of alpha is equal to the opposite side, and my opposite side is 50, and my adjacent side is 200. So it's 50 divided by 200, and alpha turns out to be a mere 14 degrees. When I subtract it from 360, I get 346.